Since there are more than 100 elements, you can see that writing electron configurations can get very tedious if the atomic number is high. Furthermore, the electrons that are farthest from the nucleus are the electrons that participate in chemical changes. Thus, the electrons that are closer to the nucleus are often not that interesting to chemists and often don't need to be considered. There's a shortcut for writing electron configurations, which is known as a condensed electron configuration, and it uses the noble gas electron configurations. The reason that noble gases are so unreactive is that noble gases have a filled NS and NP subshell, where N is the period number of the noble gases. Noble gas electron configurations can be used for the first 2, 10, 18, 36, or 54 electrons in any given element. If we take a look at the periodic table, we see that noble gases have 2, 10, 18, 36, and 54 electrons. If we look at the noble gas electron configurations from table 2.3, we see that helium, which is in the first period, has its 1s orbital filled. Neon, which is in the second period, has its 2s and 2p orbitals filled. Argon, which is in the third period, has its 3s and 3p subshells filled. Thus, whatever period a noble gas is in, the same number shell has its s and p subshells filled. To write an electron configuration that is condensed for an element, find the given element on the periodic table. Use the noble gas from the previous period, place the symbol in brackets, and continue the electron configuration. After the noble gas, you will always continue the electron configuration by starting with the NS subshell, where N is the period where the given element is. You can always use the helpful subshell chart. Stop when you've used all the electrons.